Hi, in this module 3, we are going to discuss about this PV diagram of Otto cycle and diesel cycle, right? So, in this elements of mechanical engineering, the module 3 already we are discussing about the IC engines, what is internal combustion engine, what is a diesel engine, what is a petrol engine, how they are functioning, two-stroke engine and four-stroke engine. Now, this cycle based on the petrol engine and diesel engine works on based on of Otto cycle and diesel cycle. So what is Otto cycle, how it is functioning, and what is a diesel cycle? This is a PV, pressure volume diagram, we are going to see here. So in this diagram, this is the Otto cycle, which has each and every step of the operations. That is one cycle in IC engine. That is the conversion of heat energy into the power. Okay. It has some operations like suction, compression, and burning of the fuel. It's a power stroke, then it exists. After that, again it has to exhaust the burnt gases outside. So this entire thing is called as one cycle. So this cycle carries, it starts from zero. When we are taking this image, so initial, when the piston, imagine that the piston is at the top dead center, that is near to the piston head. Okay, and when the piston moves down, it's an Otto cycle. Normally we say it's a petrol. So for petrol, we know the charge which is what we are getting inside is the air and petrol. The air fuel mixer is ready for getting inside. When the piston moves downwards, this air fuel mixture is going to be getting. So that 0 to 1, the process of the piston movement, it gives the suction. So when suction happens, the volume of inside that cylinder is going to be expanded. The volume is going to be increases, so that the fuel is getting inside, and we can see the PV diagram at the bottom. It is given 0 to 1. The 0 to 1 is carries this PV diagram. That PV diagram, it shows first position is suction. So here the volume is getting increases. After that, 1 to 2, when it goes for the second step, that is once the piston moves downward and the entire volume of entire air petrol mixer is getting, after the crankshaft is going to be rotated in the second half of the rotation, the piston moves upward. When the piston moves upward, the both the valves get closed, and then a compression process is going to be taken place. So when the air fuel mixer is getting compressed, what happens normally, the volume is going to be reduces, so as well as the pressure is going to be increases. So in this point 2, we can see that the pressure is getting increased, and then the volume is getting reduced. So this PV diagram shows that 1 to 2 is a movement of adiabatic compression process. And then we can see this third one, that is 2 to 3. What is happening is at the end of the compression stroke, burning, okay, that is constant volume combustion process. At the end of this, volume will be constant because everything is compressed, and at the end of the compression stroke, the piston is at the top, and in between the cylinder head and the top of the piston there is a gap, there is the volume, so it's constant volume. So there it going to takes the combustion. That time, spark plug, due to the spark produced by the spark plug, it goes to combust. The fuel is going to be combust. All right. So when it happens is 2 to 3, right? The constant volume combustion process is taken. So that 2 to 3, you can see the pressure is getting increases when combustion takes place. Heat is taken place. That is, the pressure is getting increases, as well as the volume becomes constant. Right. So 3, the question now from the 3 to 4, what is the next one is expansion. The burnt gases, okay, what happens is when the air fuel mixture is getting burnt, it produces enormous force over the piston, and it pushes down the piston downwards. So when it moves the piston downwards, it happens that is an expansion taking place. So expansion or power stroke, we call it as. So 3 to 4, it is a expansion process, adiabatic expansion, we will say. So the volume is getting increases gradually, and as well as the pressure is getting reduces. So this 3 to 4, we call it as a adiabatic expansion. And after that, once it reaches to the bottom, again we have to make it a, due to the flywheel rotation, that is the power stroke, it produces more power, so that automatically the piston moves upward again. So that during that one, the pressure, you can see the pressure is getting reduces because of the exhaust valve is going to open. when the exhaust valve is opening here, and the gases, burnt gases are moving, and burnt gases are moving upward and it moves outward. So this is what the 4 to 1 process we call it as exhaust gas, right? And then the exhaust stroke, actually at the end of, we can see exhaust gas is getting eliminated at the end of the power stroke. So when the piston moves at the downward, at the end the exhaust starts, so that the 4 to 1 is a constant volume exhaust opens. After that, 1 to 0 again, the full, when the piston moves upward towards the cylinder head, the entire volume of gases, which is burnt gases, or moved out. So there the volume is going to be reduced. So we can see this in the fourth one, that is a 1 to 0. So these are the basics of the auto cycle PV diagram, how it is going to be function, right? So let me see some the terms how it is mentioned over here. The process 0 to 1 is called the intake stroke. Okay, so a mass of air or air plus petrol is get inside when the valve, the piston is moving downward. So we call it as intake stroke. And 1 to 2 is a compression stroke. As I said, it's a adiabatic or isentropic compression, where the air fuel mixture is getting compressed. So there is no mechanical energy is lost due to the friction, and there is no heat energy is lost. So that we call it as adiabatic or isentropic compression. Right. So next one is the after compression, we know the combustion is going to be taking place from 2 to 3 in the position when now the piston is at 2. 2 to 3 is the ignition phase, where the piston is at the top, and there is a gap between the piston cylinder top and the piston head, cylinder head. So there the constant volume is there. The at that time ignition takes place through the spark plug. So heat is added to the working fluid by the combustion of the ignited fuel. Let it be maybe yeah, petrol. Okay, petrol engine. Since we are discussing about the petrol engine, so combustion takes place, and then the volume becomes constant. So and the expansion takes place. During the expansion is the force is created by the burnt gas. It exerts a force over the piston and moves downwards. So the expansion takes place isentropically and work done on the system. So right, this is called the exhaust stroke at the end of what is it, power stroke, and then the exhaust stroke has taken place. Right. Next, we are going to see about the diesel cycle. Okay, what is the difference here? You can see. So 1 to 2, 2 to 3, 3 to 4. This is what it is. Again, we are going to see here PV diagram. So first one is we know the compression stroke, that is when suction stroke, when it strokes from 0 to 1. It's a suction stroke. Okay, so when its suction takes place, that is the volume is getting increases and the air fuel get into that. And then now compression, we will start from the compression, isentropic compression process. Here the piston moves from BDC to TDC, and only here what is happening is the diesel cycle. Since diesel cycle we are discussing, the air fuel, that is what is the mixer, the charge which is used is only air. It's not diesel is not used here for the mixer. So only air is getting added during the suction. So when the air is getting sucked, that we call it as a suction stroke. And isentropic compression, here the air is compressed to some extent that the pressure, initial pressure is increased to pressure 2, P1 to P2, and the volume is decreases because the compression process, the piston from moves from bottom dead center to top dead center. The gap, the space in between the cylinder head and the piston head or getting compressed, the volume is going to be reduced. So the entropy remains constant here. This T1 increases, right? So we can see the temperature is getting increased at this portion of the 2. When it reaches to 1 to 2, the temperature is more and the pressure is more, right? So that time the diesel, we are going to spray the diesel through a injector nozzle, right? So when the diesel is sprayed through the injector, what will happen? So automatically it gets burned. So that 2 to 3, now we are going to see this 2 to 3, that is a constant pressure heat addition taking place. At this constant pressure, already it is getting compressed. That time heat is getting added up because by the compressor, and as well as the heat when we are adding up the fuel, then automatically it takes place there burning, and then expansion start again from third to fourth. Expand the gas, that is burnt diesel, with air, it makes a pressure over the piston and pushes the piston downwards. That it takes place 3 to 4. It's isentropic compression process or expansion process. And once it reaches the fourth expansion process, again because of the piston movement towards the top, then the exhaust valve is going to be open, so exhaust gas has to leave. We call it as expansion, that is constant volume heat rejection. Here everything is going to be same in the same way like the Otto cycle. The diesel cycle, at the end of the diesel cycle, again the 1 to 0, that means again it will move to the exhaust the gases. So this is called the diesel cycle. Only we have to see the 1 to 2, 2 to 3 and 3 to 4 is here 2 to 3 is a constant pressure. Okay, that's all. This Otto cycle and diesel cycle, how its function, we have seen this. And then in the next videos, let me see the differences between some 2-stroke and 4-stroke engines and all. Then some problems we will discuss, right? Okay, fine, thank you.